Read me what we have.
Tank closure for the site of a former petroleum products distributor. Looks routine.
No, there's no such thing as routine. With over 580,000 storage tanks in this country, each site closure is different in its own way. That's why they call us. What's at greatest risk when fluids leak from underground storage tanks?
Groundwater?
Groundwater, the source of the drinking water for over half of Americans. And people rely upon us to help and keep their drinking water clean. It's a big responsibility, Lewis. You up for it?
You bet I am.
You better be. This video is to help provide understanding of preliminary site assessment procedures for the closure of underground tank systems. We will look at the people that perform these inspections, examine the nature of the petroleum products contained within underground storage tanks, and provide information regarding the basics of tank closure inspection. Because tank closure regulations vary from state to state, this video will also provide you with directions on how to get detailed information from the different state governments who provide that information. In this state, environmental inspectors like us are the first line of defense when it comes to protecting groundwater from contamination. Other states use fire inspectors, safety inspectors, private contractors, and other designated local officials. Right now, let's meet some of those officials.
Most gas stations have had many generations of tanks, and if there were some tanks that were pulled 20 years ago that had leaked and had left some contamination, that's something you're certainly going to want to need to know.
Removal of the UST system would resolve. Has there been a historic release at that site? Are we likely to encounter free product during the excavation? Would be nice to know what the tanks and piping are made of and what they contained in the system, so that we would know what components to sample for.
There's a lot of different things you could research. First is how big the excavation may end up being, how many tanks you're going to be removing. We'll look at what has been in the tanks in the past. For instance, if they've had leaded fuels, we need to be aware of that before we go out there. Like you see on my computer behind me, we'll bring up maps and we'll look at the site. We'll try and look at aerial views of the site before we go out there and try to make sure we know what we're getting into before we get there.
Regardless of who's inspecting a site, we need to be on our toes, dotting I's, crossing T's, the whole shebang. So before we see the actual site, let's review the work we've done so far.
Right. Our work began once we were informed of the tank closure. Once we received the location of the tank closure site, I accessed databases.
Well, hold on one second. There are a lot of steps involved in tank site closure. What's the very first thing we did?
Oh, right. I accessed the EPA's underground storage tank website, where they suggested I download a copy of the ASTM Conceptual Site Model Checklist.
Good. Then?
Then I accessed databases to review existing records, blueprints, site diagrams, documents, information on the area, neighboring buildings, state water supply databases, and GIS.
The information available to inspectors varies from state to state. Why don't we hear from some of them now?
The standard steps we'll take before we go out to an excavation location, we will look through our files, see if we have any files on the location, what kind of fuel they're storing out there, if they've had a history of releases in the past that we may need to know about.
If there has been a history of leaks, that should have been reported to the state, and the state underground storage tank program should have records of that. So you certainly want to make contact with the underground storage tank program and find out whatever you can ahead of time.
Before arriving at a tank closure, I would want to know if this facility has any violations that the removal of the UST system will resolve. Would be good to know is if this system has had a release in the past, whether we expect to run into free product possibly in the excavation and how we're going to handle that. What is the depth to groundwater? You know, if there are monitoring wells in the vicinity where we might expect to see groundwater. And what has been in this, what is the UST system contained, so we know what samples to collect and what the materials of construction are.
And how will we be using this information?
To help us make our decisions.
And what kind of decision-making process? Risk-based decision-making, R. Risk. What sort of risks are posed to people and places? B. Based. It is minimizing these risks on which we will be basing our D. Decisions. M. Making. We need to make these decisions quickly, effectively, and in a way that makes the tank closure cost-effective.
Risk-based decision-making.
Very good, Lewis. Are you ready to see your first site up close? You have everything you need? Your field testing equipment? Soil sampling kit?
Check.
Groundwater sampling kit?
Check.
Photoionization detector? Protective gear? Hard hat? Safety shoes? Respirator? Camera?
Check.
Notebook? Blueprints? Schematics? Topography maps? And other paperwork.
The most important equipment to have on a tank closure is your safety equipment. Minimum safety equipment for a closure is a hard hat, steel-toed boots, eye protection, and a high visibility vest. This way you become more visible to operators of the equipment. If I'm going to collect samples, I need to make sure that I have all of my sampling jars, the correct jars, sample supplies, cooler, and ice.
Remember, Lewis, we're the eyes and the ears of the people of this state. And it isn't just inspectors like us, but in many cases local fire officials, private contractors, and other designated officials who make sure that tank closure sites across the country are left as safe and as clean as possible.
Yes, sir.
Let's go. What do we know about this site?
The site is the former home to OTM Home Fuel Services. They supplied gasoline, diesel, and ferrous hydride to local homes and businesses for 47 years. Over there is the new property owner, a Mr. Jenkins, and next to him, I believe that's the contractor, a Sam Watkins.
That's where we start. Hi, Mr. Jenkins, Mr. Watkins.
Hello.
Hey. Hi. I'm Inspector Martin. This is Inspector Lewis. We just need to confirm what was in this tank, if you don't mind.
What was in the tank, sir?
This tank held gasoline.
We've already removed 2 tanks.
Well, as you know, each tank is different.
Well, I've got the site plans and any other paperwork you might need.
Have you noticed any evidence of leaks in your preliminary evaluation of the excavation?
Yeah, you know, we've found some wet soil on the far side of the site. We uncovered it this morning.
You know what that means?
A leak.
Well, not 100% of the time, which is why we investigate every tank closure. Can I see what else you have, gentlemen?
Yeah, sure.
Thank you.
Every inspector approaches a closure site differently. At the end of the day, it's about getting as much information as possible.
The first step for a tank closure is to make sure that all the fuel is out of the UST system, out of the pipes and out of the tanks. Some contractors choose to ventilate the tanks before they remove them. Other contractors take the tanks out first. The key here is to make sure that the explosive atmosphere inside of the tank has been removed before the tanks are cut for cleaning. The next step is to remove any residual sludge types of materials and drum those up, and then clean the tank before the tank is scrapped or landfilled.
Once all the prep work is done, this standard process in Vermont, like pretty much anywhere else, you break the concrete, dig down to the top of the tank. You've got to either purge or inert the tank. Once it's not in explosive condition, the interior of the tank must be cleaned. That usually involves lowering someone down inside the tank. So OSHA confined space entry procedures have to be followed. Once that is done, the tank can then be removed from the ground, and then the soil and the groundwater surrounding the tank can be assessed.
So, there it is.
What do you think?
You tell me. What are the 4 characteristics of petroleum products that we'll be looking for?
The 4 characteristics are residual phase product, mobile phase product, often called free product, dissolved phase product, and vapors.
And the difference?
When released to the environment, petroleum products can be found in one of 4 states. When a leak spreads, it can fill the spaces in between the soil particles. As the product flows from the source of the leak towards the water table, a certain amount of residual product is retained by the soil particles. Free product remains free-flowing, unattached, and undissolved. When free product reaches the water table, it does not readily dissolve. Instead, it pools on top of the water and travels with it in the direction of the groundwater flow. Dissolved product occurs as the more soluble constituents of the petroleum product dissolve in the groundwater. This is particularly alarming because the more volatile components of petroleum products tend to be more water-soluble, more mobile, and sometimes more toxic. Vapors are created as the volatile components of petroleum evaporate. Vapors emanate through the pore space of surrounding soils. When they find their way to basements, storm sewers, or any other nearby underground pathways, they pose serious health and safety issues.
Sometimes these byproducts of a leak are obvious, and sometimes they're not. They hide, they disguise themselves. They infiltrate the local ecosystem until it's too late. Now remember, Lewis, the better information we can gather, the better the risk-based decisions we can perform. And this is where we use our most important tools first, our eyes, ears, and nose.
There's the wet soil.
Well, let's get an idea of the whole situation first. Get some photos of the tank, get a good idea of what we're dealing with, plus be aware for any noxious odors.
Vapors?
Exactly.
Why don't we use the PID and take a reading?
Great idea. Our personal observation led us to believe that there are vapors present at the site. Using the PID will help give us an accurate reading of exactly how much vapor is in the air. If the vapor concentration is dangerous according to the PID, all site workers, including ourselves, would require respirators and protective masks. It looks bad, smells bad. Now let's confirm our suspicions. When doing an inspection, you need to look over the entire tank and piping runs for any signs of discoloration, corrosion, and loose fittings. You especially want to look for hot spots of heavy rusting.
But you cannot just concentrate on the tank, even though the tank is our main focus. Careful consideration is also needed when inspecting product piping. Look for where the piping comes out of the ground for signs of rusting or staining of the soil. Problems with piping may not just concern wear or corrosion. There may be signs of leakage and loose fittings in the soil or on the cut at these locations.
Product vapor may not just be in the air, but can also be trapped in the surrounding soil. To check for vapors at various depths around the site, we will bring in a post-run tubing system. This allows us to collect samples quickly and easily from various depths. The PRT system also improves the accuracy of the data we collect. Now that we've given the entire site a good inspection, it's time to get down to where we think a leak may have occurred.
I'll take some soil samples.
Well, hold on there, partner. In this state, as a safety precaution, we take our soil samples up in the bucket of a backhoe. It's best to know your state's regulations before you visit a site.
For the first-time inspector going to his or her first tank closure, tank closures have the potential for being very dangerous. There's a danger for explosion hazard from explosive vapors and flammable materials. There's a large hole in the ground, so there's potential for entrapment from collapsing sidewalls. An inspector at a tank closure needs to be very aware of what's going on around him or her. Heavy equipment, potential for getting hit in the head by heavy equipment. Operators, they're concerned about what they're doing. They're not all that concerned about who's standing around them.
If there are people around that are experienced, that have experience with remediations, talk to them, listen to what they have to say, follow along with them if they go out and do any kind of closures, and be safe. Know the safety rules first before you do anything else, because you only get one chance at safety.
Sure, when it comes to tank closure, safety is important to stewards and to us on the job site personally, because at the end of the day, we want to go home. We can put our best foot forward in terms of getting the project done, but if we don't make it home, it really doesn't matter. So we take our time with the safety aspect, and we try to follow OSHA regulations to the best of our ability. In most cases, the rules exist because someone may have died in that manner.
All right, Lewis, what do we have?
From initial examination, I think this is residual contamination.
Why?
Well, the wet soil seems to line up with the heavy corrosion areas of the tank.
And what's the soil like?
Loose, well-draining, sandy.
What does that mean?
It means if this is a leak, it could travel relatively easily to the groundwater.
Okay then, what now?
Well, we've already got our soil samples from the area surrounding the tank, photos and notes, but I think we need to bring in an MC sampler to get some samples from down closer to the water table.
Good idea. Now for those of you who don't know what a macro core sampler is or how it works, let's check in with a pro.
So this is a geoprobe. This is the truck that we use to take subsurface samples. As I said before, subsurface samples are groundwater, soil, or soil vapor. The geoprobe has a number of rods which can be screwed together, and these rods are pushed by this hydraulic instrument right here into the ground. So once this rod is pushed into the ground, another 4-foot rod would be added to it, and they would continuously push rods into the ground until you reach the water table. The rods are then extracted out of the water table, and once the rods are extracted, you have a pilot hole which is open. That pilot hole is then filled with this pipe. As you can see, this pipe also has a threaded end. Many sections would be threaded on, and this pipe also has slots. It allows groundwater to come in and keep soil out. The groundwater, which would be sampled by the mobile lab, would see how much contamination is under the ground.
The macro core discrete sampler, also known as a geoprobe, allowed us to take soil samples from various depths without disturbing the samples themselves, improving the accuracy of our readings.
We were able to check areas surrounding the excavation pit as well. We want to be able to differentiate between a leaking tank where significant amounts of product may have been lost and product that may have simply spilled during the removal process.
Let's get these to the lab. We'll come back tomorrow and take more samples from the surrounding area as a precaution. Let's hear from our laboratory about the procedures they use to help investigate tank closures.
This laboratory is used to guide the field inspector to make an answer in the field. So samples are submitted from the field inspector to the lab, the samples are analyzed, and once the samples are returned, the field inspector has better information on how to guide him to closure at the tank site. We test for a variety of things. On the petroleum hydrocarbon side, we test for semi-volatile. Semi-volatiles are for like diesel range heating, heavier fuels. We test for volatile hydrocarbons, those are gasoline or lighter fuels. We also have a fingerprint analysis, which sort of gives us an identity to the sample that we're looking at, puts a name to it. We also have look at the heavy metals, and we also can see other type of industrial compounds that maybe are not in gasoline. In our lab, it takes anywhere from 45 minutes from when the sample is submitted to about an hour and a half, 2 hours when a result is actually produced, which is a quick turnaround time. So samples that come in, depending on the test, have to be in the right container. That's number one, very important. Second thing is the preservative. The sample has to have the right preservative if you're going to be in that container. There are certain, the third thing is it has to be at the right temperature, and it has to be a cooler. It has to be separated from the outside environment. So your samples should be kept together. There should be a trip blank to see if any foreign chemical or cross-contamination has impacted your sample. So you also have to have what is known as a trip blank or a field blank to see if your sample has been contaminated by an outside source. We work pretty closely with the field inspectors when they come in. Usually when it comes in, we want to know how contaminated, we want to hear their field observations because that's very important to us. You have to remember that these instruments, the mass spec and the gas chromatographs, are very sensitive, so they can see to very low levels. We don't want to get a sample that's extremely grossly contaminated. This would actually, what we call, blow out the instrument. So if that is the case, we would have to perform a dilution. So number one, we want to know we'll actually ask a little of the case history and try to understand what the inspector is looking for. We want to provide a good product, and that's why we're asking these questions.
New liquid is formed in the hole.
Yes, it appears to be groundwater, but we have to be sure.
Now what?
Well, now we look into all of the pathways in the area that could transport mobile product to see if any of the receptors in the area might be at risk.
That means we check any water supply wells, sewer lines, surface water like ponds, lakes, or streams, any wetland areas, and basements of local structures.
You got it. All of the homes in this area get their drinking water from wells. There's a definite possibility that the leak could have spread and the wells could have become contaminated. You still got your water sampling kit?
You bet.
Let's get to work. Closure assessments are a challenge because you can never really tell the direction of the leaked product without a detailed EMSI.
Petroleum products can add to that challenge because they're volatile. This volatility may be difficult to detect if the leak occurred sometime in the past, which allows some of the volatile parts to escape.
Once again, it's important to remember that every tank system and every leak is different.
And depending on where you are located in the country, the soil in your area may be very different from the soil just one state over or even one county over. This is the last one of the houses in close proximity to the tank site.
No noticeable odor. Let's use the PID to check any available piping to see if there are vapors entering the house.
There's the main outlet pipe from the house to the sewer. I'll check there. Nothing from up here. There's a gap in the wall where it meets that air conditioning duct. I'll check there. Nope, nothing. Guess that's good enough for preliminary screening. What now?
I want to dig some more with the MC sampler.
It's very important at that point to characterize the release, try to determine the degree and extent. If the contamination appears to be extensive, there will have to be a much more detailed site investigation, and that's beyond the scope of this discussion. But at tank closure, you really need to figure out if it's just been a small amount of product that's been released, so it's a very limited amount of contamination, or whether it's extensive. The other thing that's critically important to figure out is what sort of receptors might be threatened. Are there nearby lakes or streams, ponds, wetlands? Are there buildings nearby that could be affected by vapors in the soils? In Vermont, we have a lot of small towns that do not have municipal water systems, and so a lot of people have on-site drinking water wells. If there's been a leaking tank near somebody's drinking water well, we need to know that, and we need to know whether or not that well might be threatened.
When we first drilled with the MC sampler, we only took samples from the approximate depth of the tank. Now we're getting some deeper samples. This time we used our statewide water table map that we got from the Department of Environmental Conservation. This says that the water table lies at around 75 feet. This will help us see if the contamination ends before going down to groundwater. Remember, water table depths vary from state to state and even from neighbor to neighbor.
A detailed topographical map with clear water table markings is extremely important when inspecting a tank site. Here's the soil sample you wanted. Is that it?
Let's get these samples to the lab to see if we need to have any monitoring wells installed to help determine the degree of the contamination. While the lab does their work, we can review all of the steps we've taken so far.
When we work with a laboratory, what we do is we send them preserved samples, whether it's a chilled sample or a sample of soil or water that has a certain chemical preservative in it. And then we dictate to them what analyses we want run on the soil or water. In order to decide what analysis to run, that really becomes a conversation between you and the regulator from the state to decide what tests are appropriate given the products that were stored on the site. What you get back from the lab is a set of results in terms of concentrations of those petroleum compounds within the soil or water sample. And what those levels do is quantitatively define the amount of contamination that's left behind. You can then compare those to standards to help you decide whether your actions are complete or whether more work needs to be done.
So when we receive a sample here in the mobile lab, we take the sample and we'll put it here in the rack. This is an auto sampler. An auto sampler is used to run a number of samples at one time. It speeds up the process on how quickly we can analyze samples. Once the sample is put here, the auto sampler has an extraction needle that will come. It will actually extract part of the sample out of the vial and run it through the concentrator. Here at the concentrator, the sample is concentrated so it can be shot into the gas chromatograph. In the gas chromatograph, it is separated. There's a column in there. A column is used to separate the sample into the many individual compounds. Once it's separated into the many individual compounds, it is analyzed by the mass spectrometer, which is right here. Now all this is captured on the computer. We can actually look at this on the computer and see how the machine is performing and what the results look like.
On the laboratory results, what you get is called a certificate. The certificate will list, usually on the left-hand side, the list of analytes that particular test is reporting on. Those are called your constituents of concern. Next to that, you may have a results column that gives you concentrations in either micrograms per kilogram or milligrams per kilogram. And then the column after that, you may have certain QA/QC data that gives you an indication as to the integrity of the data. What you do with that information is you compare that to published guidelines or standards that the state has put out. And again, that allows you to make a decision as to whether your actions on site are complete, whether further investigation is necessary, or possibly active remediation.
We've got the results back from the lab.
Per state guidance, we asked the lab to test for petrochemical compounds or analytes that the state lists as constituents of concern when removing tanks holding petroleum-based products, in this case, gasoline. The results are delivered in raw data, and it's up to each individual inspector to analyze that data. If the results are below the soil cleanup objective, then no further action may be needed.
What if the results are above the cleanup objective?
Then we investigate further to delineate the extent of the contamination.
First, we downloaded a copy of the ASTM's Conceptual Site Model Checklist as a reference for our investigation. Then we did our legwork through information on the site stored in databases, documents registered with the various state and local governmental offices, and interviews with anyone connected to the tank site. We then chose risk-based decision-making as a platform for making the most accurate and cost-effective decision possible. We checked and rechecked the equipment we would need to perform the site inspection, including safety and field testing gear. Then we spoke with the owner and contractor to get a briefing on what work has been done on the site. We inspected the tank thoroughly, as well as any piping, pumps, or underground fill spouts and valves for leaks, corrosion, or loose fittings. We collected samples of the soil surrounding the site using a macro core sampler and testing any moist soil or standing water on the site. Once we determined the possibility of a leak, we collected soil and water samples from neighboring houses and businesses, as well as screening local basements for possible vapors.
Good news! You'll be getting a clean tank site closure, thereby requiring no additional inspection.
But I thought you were looking into a leak.
We were concerned about a possible leak. As you know, in this state, there have been a few instances of contaminated groundwater from leaking underground storage tanks, so we have to be thorough.
But we checked and rechecked the tank site and the neighboring buildings, including soil and water samples, and we found them all to be clean.
We're also certain that the groundwater was not affected.
Oh, that's great news. Thanks a lot.
Thank you.
The most rewarding part of being involved with the tank closure is seeing that everything is clean, that there's no chance of any petroleum impacting anybody else in the community, making anybody else sick, or causing anybody else to get hurt.
At the end of the day, if I have been to a tank closure where a leaking or substandard system has been taken out of the ground, or one that is so old that it's likely to start leaking, that's a good feeling. We've stopped contamination, or we may have prevented it from happening by closing these old substandard systems.
The most rewarding part of what I do at Stewart's is the ability to do the right thing. Stewart's is willing to spend the money to make it right. We're aggressive on the cleanup. What we feel is a great business decision in terms of completing investigation and remediation in one step while the site is already disrupted really becomes an aggressive cleanup effort as well. That's part of why we enjoy the reputation that we do in the industry and with the regulatory community. And for me, it's rewarding that I can go home knowing that I don't have to sweep anything under the rug. We're doing the right thing.
So this case is closed.
Well, closed is a pretty strong word, Lewis. Truth is, you can never be sure when you're investigating a site closure, and that's why we use
Risk-based decision making.
Exactly.
We presented a lot of material in this video, and if the topic of tank site closures is new to you,
You may want to watch the video again or read the booklet that accompanied the video.
remember local, state, and federal regulations regarding tank site closures are always changing, so you're going to want to stay up to date.
And the best way to do that is to stay in contact with your local, state, and federal agencies.
And by registering for the Lustline newsletter and attending the National Tanks Conference.
To learn more about USTs, the Lustline newsletter, and the National Tanks Conference, visit www.NEIWPCC.org.